Okay, now you really need to pay careful attention today. Your midterm test will be in the testing center next week. Okay, officially it's due by the end of next week, but since spring break comes right on top of the end of next week, it could be as late as sometime before class when we come back from spring break. Okay. So we want to construct this graph. Where after that is a basic tool for get functional. Most people have written down g of x. I'm going to write y equals g of x because we're going to graph it. So that y equals the value of this function. But most people have replaced a with 2. So you get 2 f of x minus h, and h is 12. And k is 16. And people have that. Now my question is, what's f of x minus 12? Well, f of x is a basic toolkit squaring function. So what's f of x minus 12? So this needs to be an automatic step. You need to get used to this. You need to get used to function notation, which we've been talking about for almost 2 months now. Okay. Once you understand it, it's not difficult, but people are having difficulty with it. Okay. So see what you can do with that hint. Okay, now nobody is getting this apparently. This expression is the same as this, except x has been replaced by x minus 12. I've explained this numerous times. Okay, so you really need to focus on it now. It's a simple idea. If x is now replaced by x minus 12, then you're going to replace this x by x minus 12, and you're going to get x minus 12 squared. Now, there are other ways to understand function notation. You've had assignments on it in open math. You really must lock in how to do function notation. Okay. It's going to be expected throughout the test. I'm not going to explain it on the test. Okay. So if you're having trouble with it, well, I've made up a big set of problems, 100 versions. Okay. You should be able to get some practice. And one problem, as I've said, with open math is I think people are mostly just sitting there copying down examples instead of thinking them through. In the assignments, typically you have videos on maybe a third to half the problems, and then the rest of the problems follow the pattern. If you're going back to those videos after you've worked a problem, you haven't learned the problem. Okay? If you have to look back at the video, every problem you do in the assignment, you're not going to learn the material. Okay? Now, maybe you have to do that. In that case, you better be going to these problem sets that I'll explain later. Okay? And I'll explain them in an email. You need to be able to do these things without looking at examples. And I see all kinds of evidence that all people are doing is copying down examples without letting it penetrate deeply enough that they can do it on a test or on a quiz when they come in. Okay? So you really have to focus on how you approach the material. Okay? Just getting the points in homework doesn't prepare you unless you do the homework in a way that builds the learning you need. Okay? And that's, it's a learning process. Okay? So you really need that, and you'll see how we're going to try to address that. Okay, so anyhow. So we have this, right? Okay. Okay, so there it is. There's your function. Now we've used the information I gave you, which is that G is of this form. Okay. The general form of the transformation. And there's no horizontal compression in this form, but it's easy to see how horizontal compression comes into it when we need to in another few weeks. Okay. We want to understand this much. So I gave you A, H, and K. Everybody wrote this down correctly, but nobody wrote this down. Nobody did anything with F of X minus 12, but the information is there. F is a basic toolkit scoring function. You have to know that that's the X squared function. You have to know those names. We did that in the first week of class. Okay, so you're going to have to review. Now, we have this. Okay, so we have this function. Now, what do you know about the graph of this function? Well, I'll give you a hint. We start with our usual 4x4 box. The red dot center of the lower edge. Okay. And we know that we can sketch, construct, and you're going to have to be able to construct these functions, all 5 of them. But right now, you can just go ahead and sketch the dot plot. You know, it's going to look like that. And if you don't know, it's going to look like that. You're in a little bit of trouble, so get out of trouble. Okay. But I think everybody pretty much knows that. So go ahead and sketch. But on the test, I'm going to ask you to construct all the subdivisions, label all the lines, all the points, understand what's going on in the coordinate plane. Because that's what you need in order to understand graphs and to understand functions. And to be able to use them in your subsequent education and in your field. Okay. So there it is. Okay, well, that's your basic and of course, this is 4 and this is 4. Okay, well, now what is what's the minus 12 going to do? What's the 16 going to do? What's the 2 going to do? Which one of those do you want to look at first? These are transformations. You have vertical stretch, a horizontal shift, and a vertical shift. This is something you've used in several assignments. Okay, a specific assignment on it. Okay, you can't forget it. You got to build on it. And again, one problem is that most people, and there are exceptions in here, I mean, you know, some of you did a pretty good job in constructing some of these shapes, okay? But you got to be infallible on it, and you got to be able to do it quickly. Then you can build on it, okay? I think everybody's got what they need to build on it, but I'm not sure people have been building on it. All right. So what you need to be able to do, just talk about what you need to be able to do. You need to be able to draw this and now apply these transformations. Which transformation do you apply first? Okay, now, the things that we have to know that we've tried to build throughout the semester, but they aren't building. There's your vertical stretch. Here's your horizontal shift. And your vertical shift. really recommend that you spend a significant amount of time going back to the beginning of the semester and seeing how this is built. You can flip through videos. You can look at notes if you have them. But this is something you can't not know. You should also know why. But right now, this is your scheme. So now, what's the vertical stretch going to do to this picture? You know, these transformations are quite simple. The vertical stretch stretches things out in the vertical dimension. Now I ask, what's going to happen to the vertical dimension of this square? Well, of course, some mastermind decided a decade or two ago that geometry wasn't important for anybody anymore. So they dumbed it way down so nobody knows anything about geometry. Okay, when I say vertical dimension, when I say the dimension of something, people don't know what dimension means. That's a very geometric concept that comes up all the time. Okay, so, you know, for whatever reason and whatever positive things came out of that decision, one negative thing is that people don't know any geometry and can't speak the language. Which is why I have you sketching all these dotted lines and putting in all these numbers and understanding the geometry, the very basic rectangular geometry of the coordinate system. Okay, everything I'm asking you to do feeds into developing that understanding. Because I'm pretty well convinced if you don't have that understanding, you don't have much of anything that you can use. Unless you're really good at algebra, and you know, after COVID, nobody comes in here really good at algebra. Very few people do. Some do. Okay. So we're trying to do a geometric approach. Okay, well, the point is the vertical dimension is the form. This is a dimension, this is a dimension. Okay. We could also talk about the diagonal dimension, which is 4 times the square root of 2. Anybody ever hear of the Pythagorean theorem? I've seen a lot of them. Some people have. I'm not sure everybody has. Okay. It's a little scary. Okay, anyhow. Not scared of you. You're here, you're working. So we're going to make you good. Okay. Okay, we got vertical dimension 4 here. Vertical stretch stretches out your vertical dimension where it's twice as much. In this case, the vertical stretch is 2, right? So I like to say the vertical stretch factor is 2. And I actually like to call it the vertical stretch slash compression slash reflection. Because if this number is less than 2, you're squashing the thing down. I mean, less than 1, I'm sorry. If it's less than 1, you squash it down. And if it's negative, you flip it over. But that's all comes out of this number. In this case, it's just a plain old vertical stretch by a factor of 2, which means you make this rectangle twice as high because all your y values are going to be twice as high as they would if we didn't have the 2 there. Okay. So sketch that. Yeah, sketch what I've got here. It should just take you a second, slop it down, and then sketch the thing vertically stretched by a factor of 2. Okay, when you vertically stretch this thing by a factor of 2, the vertical dimension 4 is going to be multiplied by 2. 10 2 times 4 is 8, so you're going to end up, and let's use a slightly different color here. Drastically different, blue's drastically. Okay, so now we have this. I think it's 8 units high and 4 units wide. Okay. Then what do we do? Well, we horizontally shift this thing. How much? 12 units, right? We'll read off the horizontal shift here. We're going to move this point over 12 units. Okay, well, I don't really have room here to do that, so let me just quickly redraw this thing. But what I see when people do the work, they skip a whole lot of stuff that you see me do. I'm doing it, so you'll do it too. Because if you do it, then you learn and it soaks in what these things mean. Okay, so here we go, the baby. Suppose we'll draw a really bad parabola inside of that, and maybe a little better one down here. So this parabola is y equals x squared. And this one is y equals 2 x squared. Now, I've drawn this picture before, okay? If you're reviewing the videos and reviewing the classes in the way you need to in order to learn this stuff, you will have seen this at least a number of times. And if you're not reviewing and not following up, you really need to. And you need to start. Okay, so now we shift over 12 units. Now, how far is 12? Well, this is 4. So starting from the red dot, we go 4, 8, 12 units. The red dot is going to move over to about here. Now we'll go ahead and extend our x-axis, which is supposed to be straight. Okay, then we draw this 8x4 rectangle. And I'm not doing a very good job of making it symmetric, am I? Okay. So here we have it. And here we have it. And now this is y equals 2 times x minus 12 quantity squared. And the red dot is now at the point, we've moved it over 12 units. This is going to be the point 12, 0. Now finally, we move the thing up 16 units. Well, there's 8 more. And that's going to put the red dot 16 units up here. And put our red dot about here. So we first move over 12 units. And then we move up. So this point is now at 16, sorry, 12, 16. And we can draw our 8x4 rectangle. And right here is our graph of y equals 2 times the quantity x minus 12 squared plus 16. Now we can take this rectangle and we can label the horizontal lines This is y equals 16. This line here is y equals 24. I have to put one on my 16. Okay, and this is line here is x equals 10. And this line here is x equals 14. And we've been through this extensively. Okay. And then you draw your construction lines and you label them. Now, we spent a good bit of time doing that, and people are having a little trouble with it because people aren't very good at arithmetic on this stuff. Okay. So you're going to have to work on that. But I'm going to want to see that. And we're going to want to see that, okay, if I plug, let's say 9 in here, I'm going to get a value for y. My x equals 9 line is going to intersect this line about here, and my y value here should match up with what I get from the formula. That's the whole point. It's the whole picture. Okay, now, you really need to have that picture, and not just for the squaring function. For all 5 functions. The process is the same for all of them. The box goes where the box goes, and the graph is constructed within the box. Sometimes the box has a red dot in the middle of the box, not in the middle of the lower edge, but you have all the rules for that. If you don't know what they are, write them down. Go back and find them and write them down. You should have many notes. And they've been repeated a number of times. So, you really need that. I might give you a synopsis of those rules, but I think I already have, maybe 2 or 3 times. And I don't like to do too much repetition, not that it takes me a huge amount of time to do it, but the more I repeat it, the more you ignore it. That's just natural, okay? When you get too much information, you just get overwhelmed. So I don't like to tell you 6 times the same thing that I've told you 5 times, okay? I just think it's counterproductive. Okay. Okay, now, let's just take y equals 2x squared plus 20x minus 30. What are the zeros? Now, what do I mean by the zeros? I mean where x equals 0. I think I said that wrong. Write it out correctly. So what value or values of x is y equal to 0? So how do you find out? Well, if y equals 0, y equals 2x squared plus 20x minus 30. So y equals 0, you get 0 equals 2x squared plus 20x minus 30. Okay, so how do you find the values of x that satisfy that equation? You can always use a quadratic formula. Remember what the quadratic formula is? This should be very familiar to you, even if you haven't seen it for a few years. Okay. And I think you've seen it in this class, but I'm not sure. We might have done that in the D60. Excuse me. So can you use this formula to tell me when this is zero? Okay, now this should be familiar to you from your algebra classes. Once you see this and this, theoretically, you'll know what to do. Now, it's been 10 years since you had algebra. None of you look old enough to have algebra 10 years ago. Some of you, might be old when you look, but I don't think so. Okay. And if it isn't, the point I want to make is not that there's something wrong with you, that you just have to take the time to grill yourself on this and get to where you can use it. And it doesn't take that long. Okay. You simply have to do steps. And this supplemental set of problems that I've created should allow you plenty of practice with this. So here, this function, a is a number in front of x squared, I'm sorry, b is what's in front of x, and c is your negative 30. So x equals negative b, which is negative 20, plus or minus the square root of b squared minus 4ac. b is 20, so it's 20 squared. 20 squared, not 20 to the 0, minus 4 times a, which is 2, times c, which is negative 30. And that's over 2 times a is 2. So just numbers now. And just do the numbers. You got 400 here. You got 240 here. Gives you 640. So you got minus 20 plus or minus the square root of 640, all divided by 4. And that equals negative 20 over 4 plus or minus square root of 640 over 4, which equals negative 5 plus or minus the square root of what? Well, you should be able to factor a 64 out of that and get 8, and you have 8 times the square root of 10. So you get plus or minus 2 times the square root of 10. And I'm not going to go through the details of that because it's really confusing. You can get the numbers if you just use your calculator. Now, I don't particularly like letting you do that, but on the test, you would have access to a calculator. Okay. And the square root of 10 is about 3.1, so that's going to be negative 5 plus or minus maybe 6.2. Or negative 11.2. So if you have a quadratic function, you can always do this. So you can start to make a graph. If x equals approximately 1.2, y is going to equal 0. If you put 1.2 in here and square it, you get about 2.88 and 24, a little shy. 3 and 24 minus 30. Could be something wrong with one of my numbers. T squared of 10. 640 should be a little more 25. A little over 6. Yeah, something wrong with my rounding off, but we'll just live with it. Okay, so you got the point 1.20. and the point negative 11.2 on the graph. Okay. So those are the zeros or the x-intercepts. And they occur when y equals 0. You've got to lock that in. Don't not know that. Okay, please, for your own sake. Okay, then what do we have? What's the y-intercept? Well, x-intercepts occur when y equals 0. Those are the x-intercepts. Those are the points where this graph is going to intercept the x-axis. The y-intercept is going to occur when x equals 0. This is another critical thing. No matter how many times I tell people, you just have to know that the x-intercept occurs when y equals 0 and the y-intercept occurs when x equals 0. So when you see y-intercept, you think immediately, okay, x is 0. Then you know what to do. Okay, or when you see x-intercept, you know immediately y is 0. Then you know what to do. Okay, you have to make that connection. Okay, so when x equals 0, so the y-intercept is that y equals 2 times 0 squared plus 20 times 0 minus 30 equals negative 30. So we come down here somewhere. I don't want to go that low. For reason just let's say that y equals negative 30 here. Now, the reason I put this up higher is because we're going to have a parabola that goes through these 2 points and this point. Okay. Where's the axis of symmetry? Okay, the what I got is it splits the parabola in half. Okay, so parabola is the same. On this side, it's a reflection of whatever it is on this side. Okay. Well, that means that the axis of symmetry better be halfway between the 2 zeros, right? If these are both points on the graph, then the axis of symmetry has to go here. I think I kind of missed it. That distance is a little too big, but should be a little bit over that way, but you get the idea. Now, where is the axis of symmetry? I can add these 2 zeros, and what I get is negative 5. Here's the axis of symmetry, sitting here inside your quadratic formula, smiling at you. If you know the quadratic formula, and you're going to need to know the quadratic formula. Okay. Now, when you're doing problems that apply the quadratic formula, you don't want to sit there with a quadratic formula in front of you. Yeah, first time you probably do. But every time you do one, you try to do it without looking at the formula. You try to remember the formula. You pull the formula out of memory. If you sit there doing your homework with all the formulas and everything in front of you, you never pull it all together in a way it's going to help you in the test, because you're not going to have that formula on the test. Okay? You just have to know that formula. And if you do a dozen of these problems, you're probably going to remember that formula. And if in your algebra classes you'd had to do 30 or 40 or 50 of them, you'd be more familiar with it. Okay? Now, in your algebra classes, for reasons that are maybe beyond your instructor's teacher's control, and bottom line is prepare people to do okay on the SOL test so they can then forget everything. Okay? That's the whole syndrome comes around the SOL test. And you think, somebody would have figured out how to improve that whole situation, but 20 some plus years that they've been doing. It's not a good test. Okay, anyhow. That's what you get. And that's one reason maybe you don't know this stuff in a way that really comes back to you. So you're going to have to dig a little bit. That's all there is to it. Okay. Now, some people might know that, people come through knowing these things, but most people don't. Okay, so anyhow, so we're halfway between the zeros, but that occurs right here. Because the zeros are -5 plus something, and -5 minus something, and -5 is right in the middle of -5 plus something and -5 minus that something. You understand that? It could be useful. Okay. What are the coordinates of the vertex? Well, vertex is on the axis of symmetry. Axis of symmetry is x equals 5. This number here came from your negative b over 2a, and right there it is again. And there it is, x equals 5. So the x coordinate is 5. Thus, y equals g of 5. I'm going back to my g notation because g of x is this. And what do I mean by g of 5? I mean replace x by 5. Replace all the x's by 5. Now I don't have room to write out all the numbers, but x squared is 25 and double that is 50. 20 times 5 is 100, so you have 150 minus 30. We got a problem here. No, it's -5, it's not 5. We don't have a problem. I have a problem. Okay, but that's, we fix it. I got a little careless, left the negative off my 5. So if we use -5, we have 50 minus 130, which is -80. It should be y equals -30. I don't know why I didn't put the 0 on it, but it's for -3. Okay, well, if that's -30, then -60 be here, and -80 might be about here. And here's the vertex. -5, -80. Now, well, if I want, I can draw a rectangle here and subdivide it and all that stuff. Don't necessarily have to do that, but you can understand how that would work. And right there's my parabola. Okay. This is the axis of symmetry, x equals -3. This is going to be y equals 16. So my vertex is -3, 16. Okay. So what's the formula for this function? Okay, well. Oh, phew. I don't know when I stopped this recording, but okay, well, again. I've given you this parabola. X is 7 period X equals -3. Y equals 16 here at the vertex, so that the vertex is at -3, 16. And if we think of this as a transformed squaring function, which it is, that's our point HK. Our vertex is our red dot. Okay. So we focus on that vertex, and the axis of symmetry forces a vertical line through the vertex. So we have this. And we know that y equals some transformation of your squaring function. So implicitly, f of x is the basic toolkit squaring function. So we can write this. So I've written it again down here, and I've noticed that when x is 8, y is 0. The point 80 gives me an x value and a y value I can plug into this equation. So what equation do you get? Okay, well, I asked you to write that out. Let's see if you got it. Okay, now please don't be offended. I'm just going to say that I'm really seeing a pattern of people don't seem to know what it means when I say replace x and y by 8 and 0. Okay, it's an operation that people don't seem to have done very many times. Okay, so make sure that you really understand what I mean by this. We've done it many times, but people just are really slow doing it. Okay, you want to be a little quicker doing it, and it's not hard. You just have to know to do it. So kind of focus on this idea. If we've got the values of x and y, we can replace x and y by those values. If x and y is a point on this graph, then we can replace x and y by the coordinates of those points, of that point. Okay, so y equals 0 and x equals 8. So, put it out of room down below. So, in this expression, I replace y by 0. I get a 0 here on the to the left of the equal sign. My a doesn't get replaced by anything. My x gets replaced by 8. Make sure you're replacing x by 8 and not something else. It goes along with the idea that people have a lot of trouble understanding how you use function notation just by replacing x. It seems to be a concept that people need more work on developing. Anyhow, now you can solve this. Okay, so you get 0 equals 8 times 11 squared plus 16. Okay. Now, I need a little more room over. I'm going to bring this over here. Had a good idea. Should have left myself more room, but I didn't. And I'm going to write it as 8 times 11 squared plus 16 equals 0. Okay. Now 11 squared is 121. You have to use a calculator for that. Okay. We get this. I think I saw somebody add the 121 to the 16. You can't do that. This 121 has an A dragging it around. Okay. And that 16 doesn't. So these are not like terms. And depending what the value of A is, you're probably not going to get 137 anywhere. Okay. Got to follow the rules of algebra. And this is, again, we need to work on these rules. Now, on the test, a lot of times I'll give you substantial credit for being able to write down the equation. Okay. And I might not penalize the algebra as much as I will on the final. But you should know the algebra. You're not going to get full credit unless you know the algebra. Okay. And this is elementary algebra. This is algebra 1. Okay, so you subtract 16 from both sides, you get 141A equals -16. And then you divide both sides by 121. And you get A equals -16. over 121. So now we know what the equation of this parabola is. So now that we see this, we just take this form here. Place our value of A. Okay, now we had another suggestion for how to do this. A good way, if you happen to know both of the intercepts. And actually, I don't want to, yeah, well. Okay, I'm gonna do it this way. I know from these two intercepts that this equation is of the form A some multiple of x minus 8 times x plus 14. How do I know that? I know that because if I plug in x equals 8, I'm going to get 0, right? Because 8 minus 8 is 0. And this is multiplied by everything else, I'm going to get 0. And if x equals negative 14, this one's going to give me 0. Negative 14 plus 14 is going to give me 0. So we have to be this form. All right. Then because the vertex is at negative 316, y equals 16 when x equals negative 3. So what I do, I plug in 16 for x. So I plug in negative 3 for x and 16 for y, and I can solve for a. So do that, see what you get. See if you can solve this for a. Okay, so how do we solve this equation? Well, first we simplify things. We have 16 equals a. Now, minus 3 minus 8 is negative 11, and minus 3 plus 14 is 11. We get 16 equals a times negative 121. So a is 16 over 121. Okay, so that should be straightforward. So make sure you understand how that's done. You know, this is the way I introduced the equation to the plane. It's the way that fits the picture better than anything. It's not just an equation you memorize and then screw up. Okay. Because, you know, some of that happened on the test. That's the equation of the plane. And what's it say? What's its vector? X minus 4 times I plus Y minus 3 times J plus Z minus 12 times K. This is the vector from this point to X, Y, Z. So this is the blue vector. And of course, this is the normal vector. Okay. So why should the equation be this dotted with this equals 0? Well, it's because the normal vector is perpendicular to every line in the plane. Okay. And this vector is parallel to a line in the plane since it goes from a point in the plane to another point in the plane. So the dot product has to be 0 because the two are perpendicular. Okay. This is a statement that the normal vector is perpendicular to any line in the plane. So you get this thing that you've memorized hopefully correctly. There's no real reason to memorize it if you have this picture. And this picture is much more informative than a formula that you memorize. So I advocate it. Nothing. Memorize the formulas and apply them correctly. Okay. But I recommend that you understand it a little better than that. Okay, so Z equals what? Well, you're going to have a 2x minus 2x plus 3y divided by 6. So it'd be minus 1/3 x plus 1/2 y. And then you're going to have a negative 8 here and a negative and a 9 here gives you 1. So you have a negative 1 when you get there. You add 12 and you get 11. I'm not trying to do too much in my head. What you get is twelve and 6 is 73/6. Okay, so uh, functioning 100%, but I think that's right. Okay, it doesn't matter if it is. We're going to use this. Okay. Now, I want to find the volume of this thing. So what am I going to do to find the volume? Well, I'm going to draw this 8 by 8 rectangle. Put the x direction this way and the y direction this way. And I'm going to divide it up into 16 smaller squares. And then I'm going to pick a point in each square. Okay, that looked pretty Very good. And we're going to evaluate Z at each of those points. So I estimate this point be about 0.7. At about 0.7. So Z would be about 0.2, negative 0.2 plus 0.4 is about 0.2. And that's going to be 12.1. So legal 12.3 at this point. Okay, over here, X is, I mean, here's 2, 4, 6, 8. X is about a little over 5. Y is about 1. If X was 5, you'd have negative 5/3 and half of 1. And I don't want to do all that in my head, but I could do that. I could evaluate my Z's at every one of these points. Okay. That makes sense. Then I know that on this plane, Z is not going to change by a whole lot within one of these little rectangles, one of these little squares in this case. Okay. So whatever I get for Z at a random point in each of these squares, I'm going to multiply that by the area of the square. Square is 2 by 2, the area would be 4. So that it's taking this first little rectangle. Two by 2. I've got my point about here, and my Z value is about 12.3. And then I simply so now I've got this rectangular region with dimensions two by 2 by 12.3, which gives me 49.2. Okay. Now how to get those dimensions? I took the Z function and evaluated for the X and Y that I estimated here. And now I've got a pretty good approximation to the volume contribution above this small square. Now I can do that for all the others. Okay. So I could get a volume estimate for all these things and so forth. So there it is. Does that make sense? You see how that would look? It's as though we're taking this block and cutting it in half this way, cutting each half in half this way, and then cutting it in half this way, and each half in half this way. So I've got 16 little prisms. Okay. Some of them have more area or volume than others, because some of them are at a point where Z is greater than others. But when I add all those up, I get a pretty good approximation to the total volume. Okay. That image makes sense. That's the image you want when you're doing volume intervals. A plane's easier than anything else. But, okay. Well, we'll formalize this a little more. This is going to become a Riemann sum. So I'm going to take my region again. And we understand we've got some function, some surface above this thing. Maybe it's a plane, maybe it's something else. And first of all, this rectangle, here's the origin. Okay, this region. Is a set of all points where x is between 0 and 8 and y is between 0 and 8. Okay. If x is between 0 and 8, then you're between these two vertical lines. Here's x equals 0. Here's x equals 8. So you're confined between these two lines because of this. Y is between 0 and 8. So here's where y equals 8. Here's where y equals 0. And you're confined between these two lines, which means you're confined within this square. That's a complete description of the square. And you can do any rectangle that way. Okay, just put the bounds on x, put the bounds on y. Assuming, of course, that the rectangle is oriented with sides parallel to the x and the y axis. Now I'm going to subdivide the region. And I'm going to divide it into 4 intervals. And maybe those 4 intervals are of equal length so that it's divided just like the picture I showed you before. Okay. And maybe not. But here I'm going to have x equals x1, x equals x2, x equals x3, x naught equals 0, x4 equals 8. For the second interval of the partition, where's the second interval? Well, here's the first interval, here's the second interval. About where and that's stuff against stuff. Anyhow, you see the second interval. Okay. I can let my y's go from y naught to y4, y naught equals 0, y4 equals 8. So maybe I don't divide it up evenly. Now, it's better probably if I divide it up evenly, but that's an art when you get to it later. Okay, so now I've divided this thing up into at least this strip into 4 rectangles. And then I put a sample in each one of these. So I put a sample point. Okay, well, what's the sample point? This is my second interval. So I'm going to call this point x2 star, y1 star. It's in the second x interval and the first y interval in this vertical strip. Does that make sense? You might not know why I'm doing this, but that's what it is. Okay. And then here we would have x2 star y2 star. I'm being a little careless with my subscripts because this x2 is not the same as this x2. Okay. In that case, I get sample points. Okay, so each xi star, yj star. And what do I mean by that? I is the x index. Okay. Now I'm going to do the same thing in all these other strips. So I'm going to end up with something like what I showed you before. Okay. Right now we'll just concentrate on this strip. We evaluate fi star, yj star. Volume above the increment is f of xi star, yj star, delta xi, delta yj. Maybe I do 4 equal intervals each way. So my delta xi and delta yj both be 2. That makes sense? Okay, I mean, that just comes back to this picture, but I'm putting some notation on it. Okay, then the volume above the second strip. I'm just looking at board space, so they want to make it a little more. Hang on a minute. So well, the second strip is x1 less than x less than x2. 0 less than y less than 8. But of course, the y's from 0 to 8 are broken into 4 subintervals, okay? It's approximately what? It's okay. My delta x is the delta x of the second strip, okay, which is delta x2, okay? So I mean by delta x2, it's just this width. Delta y1 is just the delta y that we've used to divide this thing up. Then we can write this out, x2 star. And that should have been y1 star. I'm sorry if I confused you. This would be the x2 star, y1 star. And it would go with the first y interval and the second x interval. Okay, well, then this would correspond to the value of f at this point, which is how high the graph is above this point. And it's x2 all. Not totally with it. I don't think I've done anything too altered. Okay, again, all my delta x's are delta x2, so I'm just talking about this strip, right? And all my x's are x2 stars because I'm using set points within the strip, so that all these x2 stars are between x1 and x2. So I could write this as the sum of f of x2 star yj star delta x2 delta yj, and j equals 1 to 4. Is that a familiar notation? Did you do something like this in your first year calculus course? Okay, so this should invoke something that you at least vaguely remember. Hopefully remember it even better. By the time we're done with this, hopefully you remember it really, really well. Okay. Well, that's this strip. So this approximate volume above the second strip. I should say the second strip, second vertical strip. Okay. And maybe the word vertical in the third down. Okay. Now, what's the total volume? I'll give you, think about this, digest it a little bit. How would you write out an expression for the total volume above all 4 strips? For the third strip, you could just kind of do it by rote. The only thing that's going to be different from the third strip is you're going to have x3 y whatever, right? Okay. So for the third strip, would be this. I mean, you could draw the third strip, and I've got it all labeled, so I'm not going to do that. But I'll do, the first strip. Okay, first strip would be here. So I have sample points. A sample point in each rectangle. And what are the coordinates of this one? It would be x1 star, because I'm between x naught and x1. That's my first strip, so I'm going to use 1 for the subscript. Okay. And y1 star. At this point, it's going to be x1 star, different y. Okay. Got to be x1 because we're between x0 and x1. We're in the first strip. For this one, it'd be x1 star, y3 star, and for this one, it'd be x1 star, y4 star. If I add them up, well, if I use x1 star, then I've got the x1 for every sample point. And I've got to use a different y. Well, y is going to be yj, where j goes from 1 to 4. Okay. So there it is. Now, little volume. That would be across. Okay, little volume will be from j equals 1 to 4, x1 and yj. Okay. Plus the sum, j equals 1 to 4, f of x2 star, yj star delta x2 delta yj. Plus the sum for j equals 1 to 4, getting monotonous now, but it's make sure we're thinking about what all this means every time we see it. Don't just write it down like have it. Understand why we're writing it down and how it corresponds to our picture. Okay. Now, if I have the foresight to leave myself enough room, but we've already disposed of the third strip. I think we understand this. So I can write all this as the sum from I equals 1 to 4 of the sum from j equals 1 to 4 of f of xi star, yj star, delta xi, delta yj. In other words, if I equals 1, then all these i's, both of these i's are 1, and I have this expression. If I equals 2, then all the i's are 2. So this and this will have subscripts of 2, and I have this expression, and so forth. Okay. This is a Riemann sum. Now, in general, when we do a Riemann sum, what use that? Let's see. I can partition this X interval into N subinterval. Okay. And I can partition the Y interval. I can partition them into N, but I don't want to use the same subscript. I'll use M. And it should be Y, not X. Okay. Anyhow, there we have it. For the ith vertical strip, right there's my volume. Does that make sense? So we can imagine we've divided this rectangle up into a whole bunch of vertical strips, because when we partition the X interval, we get N vertical strips, right? And then, of course, for the ith strip, let's say this is it. You could pick any one of them. We can divide that up. Now, if we have any kind of reasonable function, f of x, y, doesn't have discontinuities, doesn't have huge second derivatives, doesn't have pathological behavior, then dividing it up this finely is probably going to give us a real good approximation. Because within any one of these little rectangles here, these tiny rectangles that make up this vertical strip, our function f is not going to have room to change by much, because x and y are going to be able to change by much. So whatever our sample point is, our x and y is going to stay close to it. Okay, so our function f of x, y that we're trying to integrate is going to stay close to that value. But then close isn't good enough. In a minute, we're just going to take limits. Just let these things shrink to zero. Okay, well, that's for the ith vertical strip. And I should say approximately equal. Then I want stars in these things because these are sample points. Okay. The first couple of problems that you have for your homework, I'm going to ask you to do just that. I think you have something like 16 little squares or rectangles. Okay. And they tell you, okay, just here's your function. Take the sample point to be the lower left corner of each rectangle. That's not a very random sample point. But since you're going to be taking the limit as the dimensions, the delta x's and delta y's approach zero, it's not going to make any difference in the long run. Okay. If you're trying to do a good numerical approximation, then you want to be a little more sophisticated in the way you choose your sample. Excuse me.